Hey guys, how's it going? My name is Hartson, and today on my channel we're going to be continuing our journey in geometry for 6th grade math and talk about how to find missing angles in a triangle. Now recall in a previous video when we were looking at the volume of a cone and the volume of a triangular prism, a volume of a pyramid, we knew that isosceles triangles, all the angles were the same number or the same degree because they all add up to 180. Every triangle's angles will always add up to 180 degrees. So let's write that down as a fact that we know. And take this down if you're going to take notes, because this is very important. So all add up to 180 degrees. Now, depending on the triangle, some might be the same angle on two sides and a different angle on one side. Some might be all the same angles and some might be completely different angles. It all depends on what triangle it is. So here we have a right triangle, and we know it's a right triangle because this bottom left corner here, this angle, is a 90-degree angle. We know that from two ways. On the test, you're going to 9 times out of 10 on the test, if you see us at a right triangle, you're going to have this little square right here. That little square tells you that this is a confirmed 90-degree angle. And we know that because of two factors. One, this is a right triangle, and this here angle makes it a 90-degree angle. Two, we know that there's a square here. And three, we know that if we continue this line all the way here and then down here, that would make a perfect square or a perfect rectangle, and you would have 90 degrees on two sides and 90 degrees on the other two sides. Now, the way you find the two missing angles is really simple. You use subtraction. Now we know that a triangle adds up to 180 degrees, right? So we're going to take 180 and we're going to subtract the 90 that we already know from this angle here. And that leaves us with a perfect 90. Now we have 90 degrees to work with here. Now we see that there are two angles that are exactly the same, because when we drew that hypothetical shape here, the exact copy of this triangle, we know that these two angles will eventually end up to be 90 degrees, because a perfect rectangle or a perfect square has two sets of 90-degree corners that are looking at each other, right? Here, and here. So we're going to use that to our advantage. So we know that this is half of a triangle, half of a square or rectangle. And we know that these angles are going to be half of a 90-degree angle. So we know that a 90-degree angle is 90 degrees, right? So half of a 90-degree angle would be a 45-degree angle. So we're going to write 45 here and here. And why is it 45? Let me just explain it again. Because look, we know 100% sure that this angle right here is at 90 degrees. Now, if we were to flip this over and draw it again and make it a perfect rectangle, these also would be 90 degrees. Now, since there's two triangles in a rectangle or square, these are essentially just cut in half, right? Since it's a triangle. And since these are cut in half, that would mean it would be half of 90 degrees. Now, half of 90 is 45. 45 times 2 is 90, right? So these are 45-degree angles. And that's how you can tell. Now, you can check this simply by adding up all three of these numbers, and you will get 180 degrees. Because 45 plus 45 is 90. 90 plus 90 is 180. So that's for a right triangle. Let's see what we got for an isosceles triangle, which is the next explanation. Okay guys, so on our second example, we have an isosceles triangle. Now, isosceles, right, it's all the same angle. All three angles in an isosceles triangle are the same number, 60 degrees, right? So here we have a 60, this marker is not writing good, 60, 60, and then another 60, okay? Now, why is that? Because all of these angles, whichever way you flip this triangle, it's going to look exactly the same. I can't flip the board, but go ahead, if you're watching on a laptop or a computer or something mobile, go ahead and flip your screen, pause it, flip your screen, and you'll see that this triangle, whichever way you flip it, is going to be the same exact way it looks. So if we just arrange these numbers, you flip it, you can't even tell the difference. It's identical either way you flip it. Now, the way we figure it out is we essentially do 180 divided by 3, right? Now, it's going to be hard, so let's just do it the easy way. 18 divided by 3 and just add another 0. 18 divided by 3 is 6, right? 6 times 3 is 18. So you add a 0, it becomes 60. Now we have a 60-degree angle at each side, each angle, excuse me. And we use that to our advantage because essentially what we just do is we add 60, 60, 60, and we get 180. That's how it works. It's that simple. So yeah, basically 3 angles, all 60. That's how I remember an isosceles triangle, and it's unique in that factor. It doesn't have a 90-degree angle. This is never going to be a 61 or a 62. It's always going to stay 60 because an isosceles triangle, again, has all 3 angles the same of 60. And it can't be different things because this can't be 50, 50, 50 because it won't add up to 180. Or it can't be 61, 61, 62, or excuse me, 61, 61, 61. That is identical, but it won't add up to 180, right? So that's how we figure it out, and that's how you know. This has been a little quick lesson on just triangles. I'm going to be moving on to further learning missing angles and shapes and different and all that jazz. So learning the whole shebang as we go through this channel together, because it is a long journey. So if you like this video and you haven't subscribed, do consider subscribing. It helps me out a lot. Leave a like, hit that thumbs up button till there's no more thumbs up to leave. That's very cheesy. I learned it off a different YouTube channel. Don't get on me. Until next time, guys, I'm Haru Tunharian. Keep on learning, kids.